All right, today's lesson is going to be finding the measure of arcs. All right, first one here. We have a circle, obviously. Now, when you have this angle here, okay, coming from the radius AB and the radius CB, notice how they meet at the center of the circle, okay? So since they meet at the center of the circle, that's going to be called a central angle. All right, so angle ABC is a central angle in this picture. That's this angle here. Arc AC is going to be a minor arc. Now, when we say arc AC, that's from here to here. Now, here's the thing about that. The measure of this arc is exactly the same as the measure of that angle. So if this angle is 35 degrees, this arc is also 35 degrees. Okay? Next. Arc AC is the minor arc. Arc ADC is a major arc. That's from A all the way around through D to C. Now I could have named this with either E or F as well, but I chose D because we'll get to E and F later. So arc from A through D to C. Now here's the difference between these two. Notice they both have the same endpoint. Minor arcs are going to be less than 180. Major arcs are going to be greater than 180. Semicircles, they're going to equal 180. So notice how EF is a diameter. So from E through D to F, that's a semicircle. Now notice how I named these as well. Minor arcs, you're usually going to see two letters. Sometimes you'll see three, okay? But you'll see two letters. Major arc has to be three letters in the name. Semicircle, more than likely you're going to see three letters for that as well. Okay, that brings us to our postulate that we wrote down today, the addition postulate. So what we're saying is that if we take AB, add that to BC, that's going to make the arc from A through B to C. And if we gave these numbers, let's say 30 and 40, this would be 30, 40, and yes, that would equal 70. Okay? Next, we come over to congruent circles. The reason that these two circles are congruent, they have the same radius. That's all you need to know for congruent circles. If the circles have the same radius, they're congruent. If their radius are different, their radii, are different, they're not congruent. Last are congruent arcs. Congruent arcs. The arcs are congruent if they're a part of the same circle, which these two are, arc AB and arc CD. Notice how I tick mark them. Tick mark them just the way we would tick mark a segment. Okay, so arc AB, arc CD, they're congruent to each other. All right, or if they're a part of congruent circles and they have the same measure, say 40 degrees, 50 degrees, whatever it may be, then they can be congruent as well. Okay, so here we are now back doing some problems from the packet. And the first set of problems, they want to know what kind of arcs these are. So number one says arc AB. Well, if we look at arc AB, we can tell, see how EC is the diameter here? EC would cut this in half, so that would be the semicircle. So any arcs in this area here are going to be minor arcs. So arc AB, that's going to be minor. Arc AE, same thing. It's half of it's contained within the semicircle, so that's going to be minor as well. Arc EAC. Now notice arc EAC. Just notice where the endpoints are, E and C. Diameter of the circle. Arc EAC, semicircle. And then arc ACD. Now notice how it goes past. Notice how BD here, right? BD is a diameter. So that's a semicircle. Arc ACD goes past there, okay? So then arc ACD, that's going to be a major arc. You guys can do the rest of those, all right? Now, this next part here, I'm not going to do any of the problems, but we're going to fill in this circle, okay? Notice here, this is 42 degrees, vertical angle, 42 degrees as well, all right? Let's write that a little better, 42. Now, semicircle, meaning these three angles here are going to add up to be 180 degrees. So that's 106 right there. which then tells me this is going to be 74, okay? And then this angle here is actually vertical with these two. So that's going to be 138 degrees. And then remember, our central angles equal the arcs that they intercept. 74, 42, 138, 42, 64. And now you can fill in the blanks on all the rest of those problems from that group. Okay, over here, here's what I noticed. This arc PQ for number 19 is 90 degrees. Tells me 90-degree angle. These were 7s, so that tells me 7 squared plus 7 squared is going to equal our PQ squared. 49 plus 49 is PQ squared. 98 is PQ squared. 7 square roots of 2 is PQ. We just did the Pythagorean theorem. That's all that was. Okay. Here, I notice for number 21, 90-degree angle for a central angle tells me this is 90 degrees. Now notice these two arcs are the same, right? They're the same. Okay. So that tells me that 360 degrees all the way around the circle minus 90 is 270 degrees. These two are the same, so we take that 270, divide it in half. Each of these arcs are going to be 135. That should answer that question for 21. That's how you do the rest of those problems in that part as well. Next group of problems, I believe it starts with number 25. They're telling us that RS and PQ are diameters in this circle T, and that RP is 35. Well, if RP is 35, that tells me the central angle is also 35 degrees. Vertical angles, 35 degrees. QS, 35 degrees. Okay? This is a diameter. Has to be 180 degrees because it's a semicircle from P through R through to Q. These two angles together have to add up to be 180 degrees. So this angle is 145. This angle is 145. And then that tells me that these two arcs here are both 145 degrees. Okay? That fills in that circle. That should help you with those next group of problems from 25 on. Underneath it, you'll see another group of problems. I believe it starts with 28 or 29, something like that. You'll have to draw your own circle, but that's how you're going to deal with it. Okay? So what you have to do now, the rest of the day, rest of the class, whatever, this class, oh boy. Section 10.2 in the packet, page 187, 188, do 1 to 31 of the ones I didn't do, obviously, because I did 19, 21, set you up for all those. We did 1, 2, 3, and 4. So you got about 20 problems to do. I don't think it'll take too much time. All right? Remember, wash your hands, save a life.